Welcome. I hope you all are doing well. We are going to be talking today about section 1 in chapter 1, and we're going to be discussing the average rate of change. So, you may have never heard of the average rate of change, but I do know that you have heard of slope. So, most of you know that the formula for the slope is the change in the y's over the change in the x's. And typically, you know that you find the slope using 2 points, two ordered pairs that have values. And occasionally, you've seen the slope written where maybe you take y2 minus y1 over x2 minus x1. And each of these points could have a value on them. Please note that it doesn't really matter if you take y1 minus y2, as long as you take x1 minus x2. So either one is going to result in the same value. So what I want you to know is that average rate of change is the same as slope. The thing that we are looking at that's different is typically the slope is found between 2 points on a straight line, where you're finding the rise over the run. But when we look for the average rate of change, we actually can go over here to this curved line and we can do the same thing. Even though this line is curved, we can find the average rate of change, or the slope, still between 2 points on that line. Oftentimes, though, with the average rate of change is you're not always given 2 points. And so what we have to do is we have to use the given information in order to create two ordered pairs so that we can go back and find the slope or the average rate of change. So let's look at a variety of different examples in which you're going to find the average rate of change. And what I want you to do is just take notes with me. If we need to pause, we can pause and you can work through the example and then come back to the video and check your work. So the first example says, what is the average rate of change of a function? Now, that may be a word you haven't heard before. A function is just an equation. So they want us to use the equation 3 minus 2x. And they want us to find over the interval. Again, that may be a word that you haven't heard before. An interval is just a set of two numbers, and you are finding the values between that. So you're finding the interval of A to B. Okay? So we are looking for the interval between x1, which is negative 9, and x2, which is 10. So if you remember above, we need two ordered pairs in order to find the slope. Well, they give us the two x's, but what they don't give us is they don't give us the two y values. So what we're going to do is we're going to go back and use this equation. If you can see, they have an x and a y. So we're going to take the x that's given and we are going to plug that in. So we're going to take 3 minus 2 and we're going to plug in that first x value into that equation so that we can get a y value. When I plug that first value in, I'm going to have 3 plus 18. 3 plus 18 is going to give me 21. So now I know that I can put 21 here in the value. So now I have an x and a y for that particular point. I'm going to do the same thing for the next one. So I'm going to go here and I'm going to take that value And instead of putting in a -9, I'm going to put in a 10. So I'm going to have a 10 here, and I'm going to have 3 minus 2 times 10. So that's going to be 3 minus 20, which is going to give me -17. I want you to take a minute here, and I want you to go ahead and I want you to plug those values into the slope formula so we can see if you know how to do that. So take a minute and go ahead and let's see if you can find the slope between those 2 points. All right, so hopefully you wrote the value of 21 minus -17. And then maybe you wrote -9 minus 10. If you wrote that, or maybe you wrote it the opposite way, maybe you wrote -17 minus 21, or 10 minus -9. What you're going to see is that either way, here we're going to get 38 over -19, which gives me -2. And also here, you're going to get -38 over a +19, which is going to give you -2. So what you've just found is the average rate of change. It's the rate of change between those two x values. That average rate of change is -2. So that was fairly easy. It was fairly easy because it's essentially telling us what two x's we have. So what we're going to look at in the next couple examples is the x values, they don't just pop right out at us, okay? They're going to be given to us on intervals that look different. When you look at this one, it's written in the form of an inequality. Okay? That inequality is basically saying that the first x is -2 and the second x is a +3. So again, essentially it's saying, well, I'm going to give you the first x, but I don't give you the y. And I'm going to give you the second x, and I'm not going to give you the y. It's going to continue to give you a function that it wants you to use. So it's saying, what is the average rate of change on the function y equals x squared minus 4x plus 3? So like we did on the last one, we're going to take those x values and we're going to plug them in. We can use a calculator for this if we want. The thing to note here is that when we plug in these values, especially if we're using a calculator, is that we want to put parentheses when we are plugging them in. Okay, so we want to make sure that we are doing the appropriate actions when we're plugging in the calculator so we don't get an error. If you want to go ahead and try plugging in -2 squared minus 4 times -2 plus 3. When you plug that in, you should get y is 15. If you're not getting 15, it's possible that you forgot the set of parentheses on that -2. And whenever you forget that parentheses, it's not going to give you the correct value when you're squaring that number. We'll do the same thing here with the 3. So we'll have 3 squared minus 4 times 3 plus 3. And when we plug that in, we're going to get 0. So now, again, we have 2 points. We're going to take those 2 points and we're going to find the average rate of change. It doesn't matter which way you want to go about that, whether you want to call this point number 1 and this point number 2, or maybe you want to call this point number 2 and this point number 1. It does not matter which one you have go first, as long as the order in which you subtract them, it's fine. Go ahead and take a minute. We'll pause and we'll let you find the average rate of change or the slope. All right, hopefully you have 15 minus 0 over negative 2 minus 3. Again, that's y minus y over x minus x. So you're going to get 15 over negative 5. So the average rate of change is negative 3. Again, notice I'm not calling it the slope anymore. I'm calling it the average rate of change. So back up here, I'm going to make just a quick note. Remember, you're only given the x values. So given the x values, you must find the corresponding y values. And then apply them to the formula. We've seen two examples here. One, where they just give me those values. They give me those two x's. And another here where they're giving them to me in an inequality form. We're going to see something completely different in the next example. In the next example, this is called interval notation. Okay, so we just saw it in inequality notation. Now we're going to find it in interval notation. So here, this is a interval. You can disregard the brackets that are around the outside. What that interval is telling you is it's telling you the two x's that you have. You have the first x being negative 8, and you have the second x being negative 6. This is not x and y. Okay, it is not a point. It is an interval. It is saying from this x to this x. So we're going to go about the same thing. You'll notice the process just continues to repeat over and over again. It's just giving you different types of examples to look at. So we have the first x and we have the second x. And again, find the average rate of change on the function. All right, this one looks a little bit different. It gives it to me in something called function form. We're going to talk a little bit more about that as we move on through this class, but what you need to know is that f of x is really the same as y. Function notation is the same as y equals. It just happens to be that the older you get and the higher math classes that you are going to take is going to elevate the type of problems that you have. And so saying y equals is sometimes more of like an elementary type of way to write it. But we're going to leave it as y equals just so it's easier for you to understand. Again, you have those two x's that you're going to plug in. I'm going to give you just a moment to go ahead and find the corresponding y's that go along with that. While you're working on those, the last one that we're going to be looking at is going through a graph. And so you'll see we'll have 4 different methods that you might look at. When you're solving this average rate of change, we're going to later use it for some different things. So we're going to apply this skill to something else. All right, hopefully you have worked out those problems and found the answer. If not, pause the video and you can continue to keep working. First, we have negative 8. Again, I'm going to be very careful to make sure that I'm using a set of parentheses when I plug that in. I'm going to go straight to my calculator and I'm going to plug in parenthesis negative 8 parenthesis squared minus 2 parenthesis negative 8 parenthesis. When I plug that in, I get 80. I'm going to do the same thing here for the second value. So I'm going to plug in negative 6 and I'm going to get 48. And hopefully you got those two numbers, 80 and 48. All right, we're going to go ahead and come over here. Again, it doesn't matter which one. The last time I let the first point be number 2 and the second point be number 1. If you want to switch that up, you can. For example, you could say 48 minus 80 over negative 6 minus a negative 8. That's saying y2 minus y1, x2 minus x1. So it's just a slightly different order. It doesn't matter which way you subtract. Again, you could subtract the other way. You could easily say 80 minus 48 and negative 8 minus a negative 6. Either way, we're either going to get negative 32 over a positive 2, or we'll get a positive 32 over a negative 2. Either way, that average rate of change is going to be negative 16. So this last example that we're going to look at says use the graph below to find the average rate of change. When you look at this, we're kind of combining the last example that we did. So again, here we have an interval notation. So what it's saying is x is equal to negative 8, the first x, and the second x is equal to negative 2. I want to use the graph below. So I don't have an equation here. No equation. Well, there's a reason I don't have an equation, because I have a graph. So I'm going to go ahead and come over here and I'm going to find x is equal to negative 8. And I can find that point on the graph. And so I'm going to go over and find its corresponding y. Its corresponding y is negative 8. I'll do the same thing with negative 2. I'll find negative 2. I'll go to the point and I'll find its corresponding y. And then I'll go through and I'll find the average rate of change. Take a moment and go ahead and work that one out. Hopefully you have 3 minus a negative 8 and negative 2 minus a negative 8, which gives you 11 over 6. Now this average rate of change, it leaves us with a fraction, which is perfectly fine. Not everything is going to come out to be a nice, neat whole number, so we can leave it here. So what we've seen in this lesson is, number one, we're used to finding the slope. That's a skill that we already know. We know that we can find the slope by finding the change in the y's over the change in the x's. But with average rate of change, we're not given them as a whole point. So we have to do a little bit of work in order to find the x's or find the y's that correspond with those x's, and then use the slope formula in order to find the answer. Let me know if you have any questions.